Okay, we're going to go ahead and start off a new section, section 3.2, logarithmic functions and their graphs. Before I actually start, I want to go ahead and just go over some housekeeping rules just to refresh your memory. First of all, I will be back by 6th period, so I will stay after school for those that need to see me or for those that need to work on their robot. I will be back. Secondly is you're more than welcome to pause or continue the video as you need. Maybe select one person from each class period to control the computer. The next thing is for third period, Mike, can you please make sure that you turn off the projector? My remote control will be somewhere on the black cart that has the keyboard on there and the ladybug. So just look for the remote control and you should be able to press the power button twice to turn it off. And also, Holden, during fifth period, can you do the same? Can you make sure that you turn off my projector so that it won't be on during my breaks, which are right after third period and then right after fifth period during lunch. The next thing is to please pay attention because I will pick off tomorrow where the video leaves off. So I'm not going to go back and teach the new lesson. I will probably just incorporate what you should have gathered from this section and then just continue from there. And then last but not least, please make sure that you behave. I always have to repeat this in order for you to remember the consequences if you do not behave, especially second period. You know what those consequences are since you've actually have endured those consequences. Okay, we're going to go ahead and start off with section 3.2, logarithmic functions and their graphs. Let's talk about the notation. So while you're writing down the notation, I'm going to quickly give you a brief background about logs. Logs were basically used a long time ago before computers and calculators were created. And when they started to multiply maybe double digits, three-digit numbers, it was a very tedious process. So what people did back then was that they changed the base numbers of each operation in order to make it not easier, but at least quicker. For example, if you have any experience in computer science, the beginning or the first thing that you should learn is the binary system because that is the system that is most commonly used in computer science. Binary system, so bi meaning two, and that means that the most popular numbers in the binary system are 0 and 1. So if you could have multiple numbers, you can add them, subtract them, multiply them, and divide, and you can always convert them back to real numbers that you're used to seeing. The first part is the notation of it. I can take this part, which is a log expression, obviously because you see the word log on there. This A part is telling me the base. Now traditionally, in the real numbering system, we are in base 10 just because there are 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are 10 values. So normally if there is no number here, it's an understood 10. In other words, just like if there is no number in front of a variable, it's an understood 1. Well, here, if there is no number in the base part of the log, then it's an understood that we are in base 10. Now, you can always take a log expression and convert it into an exponential function. Just make sure that you kind of understand the order of it. So if you look here, the A is your base, and here you're going to take that A and raise it to the y power. And here the y is what's on the other side of the equal sign. And then here equals x, which comes from this part of the log function. So this is very important. Let's look at some examples. It says you want to change this. If I give you this right here, obviously, if I'm going to ask you to rewrite it, you're going to have to rewrite it in exponential function. Or if I gave you an exponential function and I'm asking you to rewrite it, then obviously you're going to have to rewrite it into a logarithmic function. So that's kind of understood. So again, here we are given a log function And obviously, we want to change it into an exponential function. Line up your variables. Here, the y represents 3. Your a, or your base, represents 2. And your x value represents 8. Alright, so let's write it into this function right here. A, well, here in the log function, a is my base, so here it's going to be 2. So I'm going to have 2 raised to the y power. So it'll be 3. So 2 raised to the third power is going to equal x. And if you realize x here is really the x that's in this part of your log function, which is here. So if you rewrite it, you get 2 cubed equals 8. And you know you are correct because this makes a true statement. 2 cubed is indeed 8. If it did not make a true statement, then most likely that means that you probably did not rewrite this in the appropriate way. So we have 2 cubed equals 8 as an exponential function. Alright, let's continue with this one. We have log of 8 base 2. Let's figure out what we want to do here. If there is nothing on the other side, we can just say we can set it equal to x. That's perfectly fine. A lot of math books use x. That's fine. If you want to stick to the letter y, as in here in your notation slide, that's also fine, just as long as you know that you know what you mean. Alright, so now if we want to rewrite this as an exponential function, obviously it's going to be, remember, a to the y. A represents my 2. Y in this case represents my x. And then equals x. Well, if you remember your log function notation, x here represents 8. So we really have 2 to the x equals 8. Alright, so now this brings back the one-to-one property that we discussed in the previous section. Now, the one-to-one property states that in order for you to set both exponents equal, both of your bases have to be the same. Okay, so in this case, this has a base of 2 right here, and this has a base of 8. Let me ask you, are the bases the same? No, they are not the same. So we have to make one of these sides be a base that is equal to the other. So we're either going to have to make both sides base 2 or make both sides base 8, whichever one is possible. So can anyone see which side we're going to have to rewrite? I believe we're going to have to rewrite the right-hand side, the one that has the value of 8. Because if you think about it, we can rewrite 8 as 2 cubed. Because 2 times 2 is 4, and then 4 times 2 is 8. So we're going to have to rewrite 8 as 2 cubed. Now, if we were to rewrite 8 as 2 cubed, so we would have 2 to the x equals 2 cubed. Now that the both bases are the same, we can set their exponents equal to each other, so we get x equals 3. Now I know I skipped some steps here, but hopefully you're able to follow, because this lesson or this topic was discussed yesterday and the day before, the one-to-one property. Alright, let's go over properties of logarithms and natural logarithms. And first here are the properties for logs. The log of 1 will always be 0. The log of a with base a will always be 1. Pay attention to this one. So in other words, let me give you an example. Let's see. Alright, so if I have the log of base 3 of 3, that will equal 1. So kind of think about it as if these two right here kind of cancel out. Pretend there's like a division sign right here in between them, and 3 over 3 is 1. So if you have to think about it that way, that's fine. So if the base is the same as your value in this spot right here, then it will cancel out and it will just be 1. Here, if we have log of a to the x base a, again, think about it as the same. It's as if these two cancel out with one another, leaving you with just the exponent, which happens to be x. Okay, so let's go over it again. Log of 1 base a will be 0. Log of a base a will be 1. And log of a to the x base a will be x. Now, from now on, you're going to continuously hear me say logs, ln. They're the same thing. Logarithms, right here, usually have base 10. Natural logarithms usually have base e. Now, remember, e is that constant we started discussing in the first section, and it was 2.718 and so on. So, these are the next properties of natural logarithms, which, if you notice, they are similar to the logarithm ones. Okay, the natural log of 1 is 0. These are things that you should really remember. You use them a lot in calculus, and we're going to use them heavily in the next couple of weeks. So you definitely have to remember these properties, especially because some of your pop quizzes may ask you these kind of properties. Now here, the natural log of e is equal to 1. Okay, so you need to pay very close attention because I will actually show you why it is 1. Okay, so if we have the natural log, now remember, you kind of have to start remembering that natural log automatically has a base of e. Again, natural log automatically, even though it doesn't have it on there, you probably want to start at least placing it in there. Natural log automatically has a base of e. Now, if I have the natural log of e, base e, remember, let's apply the log property from before. It's as if these two cancel out. And again, I said if you have to have a division sign in between those, it's like you're saying e over e. And that is going to leave you with just 1. So this is why the natural log of e is 1. Very important. Alright, so we have natural log of 1 is 0. Same thing with log. Log of 1 is 0. Natural log of e. Even though you don't see an e right here, it's understood because we're talking about natural logs. So natural log of e is 1. And here, natural log of e to the x is equal to x. Very similar to the third property with regular logs. Again, there's an understood e here. And it's as if that understood e with this e here cancels out with one another, leaving you with just the x as your answer. Make sure that you do remember these properties because you will use them very heavily for the next couple of weeks, in addition to calculus, no matter if you take it with me or if you go on and take it in college. Okay. So let's see what's going on here. We have the natural log of 1 over e. Alright, if you think about it, this e right here is really raised